Okay, problems 5 and 6. 5 is research to see if women pay a different amount of money than men for the same car. So you got some data what the women paid and what the men paid and their difference. Remember that the women and the men are dependent on the car. So this is not two independent simple random samples. You just can't take the women, take the men. They're dependent on the car, and you're comparing one person for that car with the other one. So they're dependent. So it's a paired comparison, which is a t-test. Simple random sample. But the population has to be normal, but we have no information about the population. We only got these little sample sizes. And then they did these little, 3 little plots for us. We don't really care about the women or the men, because that's not what we're dealing with. We would say the women look normal, the men look normal if we were doing 2 populations, but we're doing the difference. So we want to look at those differences. Again, don't try too hard, but we're just going to say that the differences, the sample difference appear roughly normal, so the population is probably roughly normal. So the numbers you want to use, you don't even have to put them in the calculator. Normally you would have list 1, list 2, list 3 is the differences, run the test on list 3. But they tell you the mean and the standard deviation right here of the differences. So we're just going to use those last 2 numbers in the chart. The null hypothesis is the mean difference is 0 between women and men. I did women first, so women minus man is greater than 0. We're trying to show that the women pay more than men. The right tail test. So inverse T of 0.95, 7 degrees of freedom. There's 8 people in the chart, right? Categories, for instance, so 7. Got a critical value of 1.89. I ran the test with those numbers in the chart. Test statistic is 3.11. P-value really, really small. We're going to reject the null. So there is evidence of alternate, or is evidence that women pay more. Problem number 6 is a weird problem. I probably wouldn't worry too much about 6. I don't think you'll see something like this, but I'll go through it quickly. So you can see it. The first one, we had a graph of length versus this fuel ratio. They gave me a line of best fit, and they asked me to find a residual for the 75. So I just put the 75 into the residual, got 4.92. The actual data point was 5.88. So the residual is 0.95. What does the residual represent? They wanted me to interpret it. The car's FCR is 0.95 gallons greater than predicted. That's all residual is. It's a prediction, right? Part B says find a point on this chart that corresponds to this. I know it's hard to see, but we're basically looking for the wheelbase is 93. So here's the 93. I have 3 choices, 1, 2, 3, but it's got to have the same residual as the other ones had. So the 1 residual, so it's up there. And then there's a point labeled B, really close to the line. What does that mean? It just means the predicted value is really close to the actual value. And then they asked me to write some comparisons about this. There's not a whole lot to say. I know they're comparing residuals, which is a little bit weird, but they're both, relatively strong relationships. This relationship's definitely stronger than that one, but both positive, both roughly linear. And which one do we want to use? We want to use the one that has the stronger relationship, which is the engine size. So that's it for 5 and 6.